Okay, welcome to day 2. We're going to go over the problem-solving process again. So as we're going through this, keep in mind George Paula's basic 4 problem-solving steps. Understand the problem, devise a plan, carry out the plan, and look back. Okay, so now on this next one, we've got a jet flew from New York to Los Angeles, a distance of 4,200 kilometers. The speed of the return trip along the same route was 100 kilometers per hour faster than the outbound speed. If the total trip took 13 hours, what was the jet speed from New York to LA? Well, first of all, we got to figure out that we're going to have some variables. Identify the variable. Jet speed from New York to LA is x. Okay. Then express all unknown quantities in terms of the variable. Okay. Well, I got a speed from LA, New York to LA, and we got the speed from LA to New York. Remember, it was 100 kilometers faster. Okay. And it was 100 kilometers per hour faster. So I got to keep in mind that my distance equals rate times time. And I'm really talking about time here because my total trip was 13 hours. So in able to get my time, I got to take distance and divide by my rate. So time is distance divided by rate. So from New York to LA, I've got a distance divided by my rate of my time out, rate 1, okay, from New York to LA. My rate 2, distance divided by my rate, was LA to New York. So this is time and this is time, and that'll be my total time. And I know my total time already is 13. So now let's talk about that. Both of them are 4,200 kilometers, and I've got my speed of x, or my rate of x on the way out, and I got 4,200 divided by my speed or rate on my way back, x plus 100, and my two times, these two times, add together to be 13 hours. Okay, so I'm going to multiply by x times x plus 100 to clear my fraction out. So my next step is this, and now I got to distribute and combine my terms, and then get things solved across the equal sign. So I got 4,200x, 42,000, or 420,000, and then I got 4,200x, 13x squared plus 1,300x. So that's why I'm going here. And now I'm going to get everything over on this side. And the reason I'm going to the right is that way I want everything positive. Okay, and then I can rearrange stuff as I go. So I got 13x squared minus 7,100x minus 420,000. Now, after I do that, I start looking at it, it's like, well, you know, I can factor this, but let's go to quadratic formula. I've got 13 minus 7,100 minus 420,000. So I have 420,000 there. So now I plug this into the quadratic formula, and using my calculator, this is what I get. Check, and make sure, a couple times, make sure that's what's going on. Now, when I put this in my calculator, let me show you a couple tricks with that calculator. I just want to make sure you guys are aware of a few things, because there are some things I pull when I'm doing the calculator that, you know, I don't think about until it's happening. And then I'm like, well, maybe I should explain that to students because that wouldn't be such a bad trick to know. So keep in mind there's a recall function on your calculator. Some people are aware of it, some people aren't, but it's the main reasons why we don't let you share calculators during a test, because you can pass answers. So here's the deal. If I'm putting this in, and what I'm putting in here is my 7,100. So I'm going to get to my second quit. I'm going to clear that. So I got my 7,100. Now I'm going to put a left parenthesis in there, 7,100. I'm going to add, now the square root of 7,225, 1, 2, 3, 4, and that is not what I wanted to do. Second quit. I'm not sure why it's doing that. I'm not happy with that. Sorry, guys. I screwed up. Let's just wait for something to happen. Gosh darn it. There it goes, maybe. Okay. Second. Quit. I'm not really sure what it's doing. Second. Quit. Okay. So for some reason, I hit something. But we're going to assume that. Second, square root. And I've got 7, 2, 2, 5, and then 4 zeros. Okay, now keep in mind, this whole thing is supposed to be divided by 26. Okay, so now I hit enter and I get 600. I can hit second recall and then arrow back and just change my plus sign to a negative, and I've got it made. Your calculator actually is a little faster to do this with. Okay, so change it and hit enter. Now these are my two answers. That negative doesn't seem to make sense because 600 is my rate at which I am flying, my speed. Negative 53, although it works in the formula, and if I graph it, that's where it would cross at negative 53.846. It doesn't make sense for this problem whatsoever. Okay, so in answering my question, I've got to realize I have these choices, but this one doesn't make sense. So when I'm looking at the steps, I have understood the problem, I devised a plan, and I carried it out. But now I'm looking back and go, you know, this one's not making sense. So the jet flew 600 kilometers on the way from New York to LA, and then it flew 100 kilometers faster, 700 kilometers per hour from LA to New York. So I hope that helped. I hope the stepping through was okay. If you have any questions, I'll be more than happy to answer those in class if you have them. Okay, so let's go on to the other one here. This one's something you've seen before. Okay, because of an anticipated heavy rainstorm, the water level in a reservoir must be lowered by 1 foot. Opening spillway A lowers the level by this amount in 4 hours, whereas opening the smaller spillway B does the job in 6. How long will it take to lower the water level by 1 foot if both spillways are open? Now, I'm going to identify the variable t, time to lower the level 1 foot if both spillways are open. So remember, in this first one, spillway A was 1/4 of it will be done. It'll lower if spillway A, all done by itself, 1/4 of it will be done in an hour. Spillway B, 1/6 of it will be lowered in an hour. Okay, so it'll take 4 hours for spillway A, it'll take 6 hours for spillway B, and then whatever the level, it's 1/4 of it that's completed in an hour for spillway A, 1/6 of it will be completed for spillway B. So what I have here is that the time in 1 hour, okay, the amount that will be lowered in 1/10 of an hour, or 1/10 of the job, I should say, time the job's going to take, is this 1/4 of the job will be done in an hour here, and 1/6 of the job will be done in an hour by spillway B, by spillway A, together, okay, in 1 hour's time, you know, teeth, so that T is in time in hours of how long the job will totally take. That's what we're solving for, is T. So the amount of job completed together in an hour is this, okay? So now I just solve for T. So I'm going to multiply, well, I'm going to get my like denominators. I multiply by 3 over 3 here to get 3/12, multiply 2 over 2 here to get 2/12. Okay, so I got 5/12. Now I'm just going to solve for T. I'm going to take the reciprocal, or do a cross product. Let's do that instead of doing the reciprocal. I got a cross product here, and I got 12 is equal to 5t. Well, I divide by 5, and I find out that my job will take 2.4 hours to complete. Okay, so that's my t, 2.4. Now, I want you to be aware of something, that this labor problem, if I have 2 people that can do a job at for a certain amount of time, I can combine them. If person A was able to complete the job in A time and person B was able to complete the job in B time, I could actually shortcut this a different way. In general, 2 people working together, this is basically what I did. If I multiply by T times AB, I get AB equals TB plus TA. So I get T times B plus A. Well, if I divide by the B plus A, this is a situation that you've seen before. In this situation, you've done this in Algebra 2, but I derived that formula based on this property and the things that were going on here. But now let's just practice. One of the spillways open for 4 hours, the other for 6. 4 plus 6 is 10. And this is 24 divided by 10, which is 2.4 hours. So I'm able to show you a shortcut for two people with a formula. But generally, this is the steps it would take, okay, as I do this. So keep in mind, my interpretation is it would take 2.4 hours, or 2 hours and 24 minutes, if both spillways were open to lower the reservoir by 1 foot. Okay, I hope that makes sense, and things are going well for you on those problems. Okay, this is the end of day 2, guys and gals, and day 2's homework is right here. And here's day 1 homework, just in case you didn't see it before. And I hope things are going well. Thank you for your time.